Hey, welcome back everybody. This is 12.1 Part 2, also known as 12.1b. Alright, so now, the reason I showed you factorials at this time is we use factorials when calculating something called a permutation. What I just talked about with fundamental counting principle was when I had different categories of things and I wanted to pull one thing out of each category. What we're going to talk about with a permutation is what I want to do when I pull multiple things out of a single group. I'm going to say more about that as we go along. In a permutation specifically, when I pull these things out of a group, we want to order the objects in a specific way. So a general definition of permutation is a ordering of objects. The key word that you want to think about when you think permutations is that order matters. Order matters is the key word you want to think about. So here's what I mean by ordering objects. Let's suppose that I had the letters A, B, C. So what I'm going to do is I'm going to find all of the permutations of the letters A, B, and C. So I'm finding the permutations of the letters A, B, and C. Alright, A, B, and C. Here's all the ways I can rearrange them. That's basically what I'm asking for, all the ways I can rearrange those letters. So I can rearrange them A, B, C. I could do A, C, B. I could do B, A, C. I could do B, C, A. I could do C, A, B. I could do C, B, A. And that's it. So if I was going to ask you how many permutations are there of the letters A, B, C, there are 6. There are 6 ways I could rearrange those letters. So there are 6 permutations. So again, a permutation is us selecting some items and rearranging them. So specific order. There are 6 permutations of those letters. There is a formula for permutation, and here it is. I call this NPR. P is a normal letter and N and R are both subscripts. N represents the number of items in the group you're selecting out of. So I'm going to say number in the large group. Number in the large group for N. And for R, it's how many I want to select and rearrange. How many we select and rearrange. And it's always specifically arranging things because we have another thing called a combination, which is only selecting only. So N, how many are in the large group, R, how many we are selecting and rearranging, and here is a formula. I do N factorial divided by N minus R factorial. Make sure you have that written down correctly. Now, I put that on that page because I was running out of space, but when we flip over to the back, I'm going to copy it down at the top as well, and I would recommend you do so that we have it when we're doing the rest of our notes on the back side here. Alright, pause to write down or flip to the back when you're done. So again, I'm going to just write it over here so we've got it. NPR equals N factorial over N minus R factorial. Alright, and this is just another shortcut that I can use to count items. And one thing that's somewhat confusing to students sometimes is that a lot of these problems actually have multiple ways that you can do them. Example 4 is the first type that's like that. It says 12 skiers are competing in the final round of the Olympic freestyle skiing aerial competition. How many different ways can the skiers finish? As in first, second, third, fourth, fifth place. Okay, so I could do this using the fundamental counting principle. And here's what I would think if I was doing fundamental counting principle, what we learned on the front page. There's going to be 12 skiers total, so I would have 12 blanks. And I'll write more in a little bit. I'm talking about how many ways can they finish. So this would be first place. How many people could I pick for first place? Well, there's 12 when I start out with. But once one person has gotten first place, there's only 11 people left to get second place, 10 people left to get third place, 9 people left to get fourth place, and so on. And so this is going to keep going all the way until I get to my very last person who is getting 12th place. Now, instead of typing all of that into your calculator, that is the same thing as doing 12 factorial, because it is itself and every number below it. 12 factorial okay, that would be 479,001,600. And so that, we just did that problem using the other stuff we learned. Now I'm going to do the problem using the new permutation stuff we learned. So if you wanted to use a permutation, here's what you would want to think of. I've got 12 people in my group, and this time I am taking all 12 of them and rearranging them in order of finish. So 12 in the group, all 12 are being rearranged, and if I typed that into my calculator, or if I used the formula, I would get the same answer. So let me show you something really quick. Let's use the formula. So n is 12 and r is 12. Here's what happens. 12 minus 12 is 0. And math fact that you need to have memorized, 0 factorial is 1. So that whole thing is just equal to 12 factorial, same thing we got when we did it with the fundamental counting principle. So again, there are several methods to do some of these problems, which makes it kind of confusing for some students, honestly. Let's do another one. Okay, part B. How many ways can 3 skiers finish first, second, and third place? So here's what you want to think of this time. I'm taking all 12 skiers in my group still, but this time I'm only selecting 3 of them. I'm only selecting 3 of them, and I want to see how many ways could they finish in these different places. So I am specifically arranging the people. So if I'm going to use my formula, again, 12 is n, and r is 3, and I'm using this formula up here when I'm plugging this in. And I'm going to show you how you can do this by hand, and then I will show you how you can type it into your calculator. 12 minus 3 is 9. So here's what's happening. If I was going to do this by hand, if I was in an emergency situation, didn't have my calculator, we know 12 factorial is 12 times 11 times 10 times 9 times 8, so on and so on. 9 factorial would be 9 times 8 times 7 times 6, and so on. You may notice I have a 9 on top and a 9 on bottom. I got an 8 on top and an 8 on bottom, but anything divided by itself is equal to 1. So essentially all of these things from 9 all the way on down are all going to cancel each other, and only 12 times 11 times 10 are left over. And if I'm going to do this problem by hand, that's really not that bad to type in my calculator. That's just 1,320. Alright, let me show you how to type this into your calculator now. So let's suppose I want to type 12 permutation 3 into my calculator. Here's what we're going to do. In your calculator, first type the number 12. First type the number 12. Then go back to that math probability section we were at before, and it's NPR. That makes sense, huh? And then type in a 3. And if your calculator is fancy, it might actually plug in the 12 for N and the 3 for R. Mine's not fancy, so there I am. 1320, voila! Same answer I got when I did it the by hand way. Cool. Let's do another example. Example 5. You have 5 different homework assignments to complete this weekend. The question is, how many ways can you complete them? So when they say something like this, they're talking about us taking 5 assignments. I am going to select all 5 and rearrange them. So I'm selecting all 5 and rearranging them. Alternatively, if you look at part B, and how many ways can you choose 2 assignments to complete on Saturday, out of the 5 assignments, now I'm only selecting 2. So hopefully you see the difference. Here I'm rearranging all of them. Here I'm only going to select 2 of them and rearrange them. I'm going to pause the video. Why don't you pause and type that in the calculator or do it by hand and see if you can get the correct answer right now. Alright, check your answer. See how you did. So we should get 120 for example 5A and 20 for example 5B. Again, please mark these if you want me to do these in class so that you will remember tomorrow which ones to ask me about. Example 6, I'd like you to read this one and see if you can get the setup and the answer on your own before I say anything. So pause right now and try these 2 problems. All right, if you have unpaused, example 6a, you should have 10 permutation 6 for your setup, and the answer is 151,200. And for part B, you should have 10 permutation 10, which is 3,628,800. Again, write down questions if you have any. Last but not least today, we're going to talk about something called distinguishable permutations. So let me give you an example really quick to tell you why I would need something like distinguishable permutations. So for example, this one is optional to write down. You can just watch if you want to. Let's say that the library has 3 copies of the book New Moon, and they have 2 copies of The Hunger Games. On the shelf, you want to figure out how many ways you can arrange these. Let's assume that both copies of The Hunger Game looks exactly alike from the outside. Let's assume all 3 copies of the New Moon look exactly the same from the outside. So for New Moon, I'm going to say N, and for Hunger Games, I'm going to say H. So let's say that I'm going along, I have the books arranged like this. Then I'm going to go along and I'm going to arrange the books like this. And what happened was I took this copy of The Hunger Games and I moved it over there, and I took this copy of The Hunger Games and I moved it over there. But those 2 arrangements, if you hadn't known I had moved the 2 books, it looks exactly the same. Doesn't look like anything changed. So the thing is, if I want to count how many distinguishable, that means how many things are actually different from each other, I don't want these repeats that happen if 2 of the items that I'm rearranging are exactly the same. So distinguishable, I don't want those repeated things. So my formula for distinguishable permutations is a little bit different here. We're still going to have on top n factorial, the number of letters or things being arranged. So that's still the same as before, or the number of items in the large group, I could also say. But here's what's going to happen. On bottom, we're going to divide off. We're going to divide off the things that repeated themselves. So I'm going to call this Q1 factorial, Q2 factorial, and so on. And this is a little confusing, so please make sure that you ask me tomorrow to talk about this more if needed. I'm going to kind of run out of time here, so I might need to anyways. And Q is the number of times that that thing is repeated. So let me show you an example to make it more clear. Example 7a, find the number of permutations of the letters in the word Connecticut. Okay, so first of all, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 letters, so N is 11. And then here's what I mean by this Q1, Q2, Q3 stuff. If I look at this word, there are 1, 2, 3 C's being repeated. So to divide off all of the extra rearrangements that are not distinguished from each other, I use a 3. So 3 represents the fact that there are 3 C's. And then I look and what other letters are repeated. Let's see here. It looks like the N's are. There are 2 N's. So I'm going to have 2 factorial to represent the N's. Then there's also 2 T's. So I'm going to have 2 factorial to represent the T's. And then one way you could think about this is there's only 1 O, there's only 1 E, there's only 1 I, and so on. So really it's 1 factorial, 1 factorial, 1 factorial for all those letters that don't have repeats, but when I multiply by 1, it doesn't change it at all. This is my setup that I type into my calculator then, and last cautionary note I want to give you, when you're typing in factorial, you need to put these in parentheses. If I don't put these in parentheses, I will get the wrong answer. Please right now try typing that in and seeing if you can get the correct answer. You should get 1,663,200. And number one mistake I get with this type of problem is incorrect calculator entry. So again, please, please, please try this right now. Example B and C we will finish in class. So stay tuned for that. Thanks for listening and hope you have a great night.